part 2 of the mini unit quiz preview. Graphing problems at the end here, 15 through 18. So, a couple reminders. One, I know it doesn't ask in the directions for your transformations or shifts, but it's a good idea to jot them down, especially if you're going to use the parent graph. So, keep that in mind. What do my 3's represent here? What direction am I going to be moving for my shifts? Left 3 and up 3. Because again, inside the radical is my left and right. Opposite sign of what I would think. Outside's up and down. So, if I'm going to use the parent graph, remember, the parent graph just consists of the perfect squares between 0 and 10. So 0, 1, 4, and 9. And the y column is just the square root of those values. Now this isn't my final graph, but what we can do is we can put some little tiny dots here where those values are. And then what I would do is take those 4 points and I'm going to do my 2 transformations. I'm going to do my 2 shifts. So I'm going to go left 3 and up 3. Left 3, up 3. Play connect the dots. Now here is where, though, the advantage of doing it this way is going to come in. And I'll show the graphing calculator way in just a sec. When I go to do my domain and range, reminder, okay, again, domain is my x values, range is my y. Domain goes from left to right. Normally, if I look, here's my furthest point left. I'm at -3, and then it goes forever to the right. For range, I'm going bottom to top. So my lowest point on the y side is at 3, and going up forever. But normally, these start at 0. They both do, and I'll answer that in just a sec. But since I went left 3, if you start at 0 and you go left 3, you end up at -3. For my y, which is my up and down, if I start at 0 and I go up 3, I end up at +3. So I can get some help on my domain and range, even though I'll have the graph there to help me. Yes, sir? I think the directions are exactly the same. I'm not 100% sure off the top of my head, but be prepared just in case. Now, if you're like, okay, me and memorizing little things like this, yeah, probably not so much. Okay, all is not lost. You can go to the y equals if you want to go this route and type in x plus 3, but remember to hit your right arrow so you don't stay underneath. And then when you look at your chart, there's -3, 3, there's -2, 4, there's 1, 5, there's 6, 6. I can get the same points. So either way is going to work. Just
I still don't get why the range is like 3 to positive infinity.
Okay.
Because like if it's going up and down, wouldn't it be 0 to positive infinity?
Okay, because here's my actual graph though that I'm using. So this is the lowest point on that graph. So one thing I'll mention, I had somebody in my last class say sometimes they get confused, especially when it comes to the domain and range part, if there's 2 sets of dots, because they're still thinking this. So she had mentioned she still writes this, but she'll put her pen at 0, 0, but she won't put the dot. And then she'll just do the left 3, up 3. And then she'll just put her pen here, but won't put the dot. Left 3, up 3. And then there's only one set of points. So that might not be a bad idea. Actually, we'll do that on the next one. When we get here, we'll try it out and see how this works. So speaking of, still a square root. Here's a difference, though. I have an a value this time. There's a number in front of my radical. That's going to change things a little bit. So if you're a charter, we're going to have one extra little mini column this time. because now that I have an a value, I have to multiply that by what's in my y column. Okay, just the y's. So multiply 2 times 0, 2 times 1, 2 times 2, and 2 times 3. Those would be my parent points this time, like the black dots that I had on the first graph. I've only got one shift this time, though. And it's right 2. So, if we use the method we just talked about, my first point's at 0, 0. I'm just going to put my pen or pencil there. I'm going to go right 2. I'll put my dot. Now, like my next point, 1, 2. 1, 2. Okay. Go right 2. My dot. 4, 4. Okay, there's my original point. Right 2. Put my dot. And finally, 9, 6. Okay, we're a little off here. 9, 6, and right 2. Holy cow. Over in the middle of my chart. And I've got my shifted graph. And again, calculators, I will get you set up here in just a moment. So here, okay, my domain. Did I move left or right at all? Yeah, I moved right too. So my domain, instead of starting at 0, starts at 2. Even though I could look at the graph and see the same thing. My range normally starts at 0. Did I move up or down at all? No. So my range is still at 0, which again I could see even if I looked at the picture. Those are the types of things I've got to think through when I'm doing these. And again, if I'm going to be a calculator folk, which is A-OK, all I would do is I'd type in the 2 first, then do my x minus 2 and pull my chart. 2, 0, 3, 2, 6, 4, 11, 6. Both work, both are successful. So in the last two, small change, cubed roots. Excuse me. So we'll get these up here. Now here's the nice thing I'll tell you in advance for both of these. Domain and range should be the easiest questions on the whole quiz. We're going to have arrows everywhere going both directions. So the domain and range, even if it shifts, doesn't matter. Negative infinity to infinity. So again, now it just comes back to, are you going to be a parent grapher or a calculator? So here with cubed roots, we're using, cubed roots, positive and negative. And the cubed root of each of those values. So let's see here. Looks like left 4 and down 4. So I'm going to start from the bottom and work my way up. So if I start at 8, 2, and I go 1, 2, 3, 4, 1, 2, 3, 4, 1, 1, 2, 3, 4, 1, 2, 3, 4, 0, 0, 1, 2, 3, 4, 1, 2, 3, 4, negative 1, negative 1, 1, 2, 3, 4, 1, 2, 3, 4, and then the negative 8, negative 2 is going to be a little bit of a problem. 1, 2, 3, 4, 1, 2, 3, 4. And I get my graph. Calculator people, you get a little bit more of a challenge this time. Because finding the cubed root button is not always easy. So what we typically will do instead is we'll just take things to the 1/3 power. Because that's what a cubed root actually is. And then just make sure the -4 doesn't end up in your exponent. And you'll end up with the same points. -5, -5, -4, -4, -3, -3, and 4, 2. And you're set. And finally, again, charters unite. And just like we did up in number 16, I have an A value this time. So I multiply all my Y values by 2. And again, I've got the double shift working here. So again, I'm going to start at the bottom and work my way back up. So 8, 4, 2, 3, 4, 1, 1, 2, 1, 0, 0, 2, 3, 4, 1, -1, -2, 1, and -8, -4, 2. And the only difference for my calculator people, you're going to type in a 2 before you put the parentheses in on your x plus 4. So that basically covers everything that we're going to have here. And then again, if you need a multiplication / factoring chart, cool. Otherwise, it's brain power and calculator power tomorrow.